Hi, Maddie. Before I begin, I just want to say that I think your student is very lucky to have you as a tutor. You are dedicated and you're just wonderful. So it just warms my heart. Anyway, so let's talk about the change of base formula for logarithms. I think you understand why we need it, but let me just review that very quickly. So on a calculator, there are two buttons that we have, which is the log button, which means log base 10, and then there's the natural log button. And so if you get in a situation where you have a different log, like log base 2 or log base 5 or log base 4, well, then the change of base formula comes in handy. So let's just quickly go through logarithms. So like if I have log base 2 of 16, well, we can do that one by hand, right? We ask ourselves 2 to the what is 16, and of course the what is 4. And therefore, we would say that the log base 2 of 16 is 4. That being because 2 to the 4th is 16. Where we get in trouble, or not in trouble, but where it gets a little more difficult is what if you have to find the log base 2 of 13, for instance. Well, this you can't do by hand, and that's where the calculator buttons come into play. Change of base rule will tell us that that's equal to the natural log of 13 over the natural log of 2, or the log of 13 over the log of 2. Now, it's really kind of cool that both of those expressions are equal, right? It doesn't matter whether you use the natural log button or the logarithm button. So let's explore why, all right? So let's go back to our basic definition. So if I have the log base b of any number m, well, that is equal to something. I'm going to put p because really, in essence, a logarithm is a power. In other words, the log base b of m equal p is equivalent to saying b raised to the p equals m. And in these cases, right, we're always assuming that our base is greater than 0 or our b is greater than 0. So at that point, we can say, okay, let's take this statement, b raised to the p equals m. And since b is greater than 0, this is a one-to-one function, and we can actually take a logarithm on both sides of this equation, and that be any logarithm. So I'll just call it log base n for any logarithm. So if I take the log base n of b to the p, that has to equal the log base n of m. Now, by our logarithm rule that allows us to move our power from the right here, we have that logarithm rule that allows us to move that power down the front, right? So log base n of b to the p is the same thing as p times the log base n of b, and that's equal to the log base n of m, and therefore p is just the log base n of m divided by the log base n of b, if we divide both sides by log base n of b. And that's what we were trying to prove right here, right? Well, one more step. What was p? Go back to the very beginning, right? What was p? Well, p was just what we had originally stated was the log base b of m, and therefore we can have the final statement that the log base b of m equals the log base n of m, where n is any number, over the log base n of b. Ta-da! And it all really goes back to the definition right here, the basic definition of a logarithm. And it's a very useful tool, especially if you're trying to calculate logarithms on a scientific calculator. I hope this makes sense. If you have any questions, just let me know. And I just want to tell you, too, you could look this up. It would appear in any pre-calculus book or college algebra book, probably. I tend to refer a lot of students to OpenStax, too. So if your student wants to take a look at more rules or practices, they could look at OpenStax.com. Okay, thanks, Maddie. And now we're going to go ahead and I'm going to also videotape your other problem, which was the limit problem.